In our journey through phylums of life, we have come to vertebrates. Chapter 17 and 18 are both over the different vertebrate phylum. Chapter 17 is over what they call the ectothermic vertebrates, and chapter 18 is over the endothermic vertebrates. So we're looking at, in chapter 17, animals that have a vertebral column and whose internal temperature is controlled by the outside. And then chapter 18 is animals with a vertebral column whose internal temperature is maintained within their own physiology. So we're looking at those two groups. This is going to be the one lecture from me, just kind of setting the stage over what is a vertebrate and giving you some quick examples of the different kinds of vertebrates. And then beginning tomorrow, you're going to be doing a project where you will take one of the vertebrate phyla and learn about it and teach the group in some presentations that will be Friday and Monday. So this is just a level setting introduction to the concept of the vertebrate, and then you're going to go into the details yourself. Okay, here we go. Take a moment to write that down, please. Okay, so all vertebrates, all members of the phylum Chordata, have a notochord at some point in their life. A notochord is a tough bar of tissue that supports and protects the spinal cord. It's not a bone necessarily. It's some rigid piece of tissue. Most chordates will then later on replace that with vertebrae, with segments of bone. But some don't. Some have a notochord throughout their entire life, and some only have a notochord for a little while and then get rid of it. There's a really weird group of chordates called tunicates that I'm not going to assign anybody to do because they're weird. I'll cover them here in just a little bit. But they only have a notochord as a larva, and then the adult form does not have a notochord, and so or a vertebrae or a spinal cord, really even. And so they're strange, but most all chordates have this notochord as a embryo and they replace it with bones later on in their life. The nerve cord itself is on the dorsal side of the animal. So a chordate has a dorsal nervous system. As we've been dissecting animals, some animals had a ventral nervous system. Matter of fact, the bugs that we were just in, arthropods, have a ventral nervous system. The nerve runs down the belly side. And in a chordate, the nerve runs down the dorsal side. And so this is it's kind of an interesting question to pose to evolutionists, because if they're trying to tell you that all life arose from a common ancestor, right, then we have essentially an animal that at some point turned upside down, because our circulatory system is ventral. Chordate's circulatory system is ventral. The heart is on the ventral side, and the artery is down the ventral side, and the nervous system is down the dorsal side. But arthropods, the dorsal system, the dorsal side of the animal is the circulatory system, and in mollusks, the dorsal side of the animal is the circulatory system, and in arthropods, the ventral is where the nervous system is, and for chordates, the dorsal is where the nervous system is. And so, if they're going to try to tell you that there was at some point a common ancestor to mollusks and arthropods and chordates, then at some point the chordate animal had to start living upside down. And why did that happen? And we don't find any evidence of the inverting of the nervous and circulatory systems anywhere in the fossil record. So it's just an interesting thing. Chordates are upside down to above as far as how their organs are arranged. So they have this dorsal tubular nerve cord. And then they also have embryonic pharyngeal pouches, which means that the pharynx, where in your body is your pharynx? Does anybody know? Yeah, it's the top of your throat, back of your mouth area, where your nose, your mouth, and your throat all meet. That's called the pharynx. So back here somewhere, right? And in your embryonic stages, you had pouches pooching out of that part of you. Now, if you're some kind of water-dwelling chordate, those pharyngeal pouches turn into gills. That's where the gills come from. And if you are not a water-dwelling chordate, then those pouches actually turn into jaw bones eventually, and your facial bones develop from those pouches. So the pouches do two different things. They become two different things in chordates depending on what kind of creature that chordate is going to become, but they all have those poochy pouches as an embryo. So this has caused evolutionists to say that terrestrial mammals' jaws evolved from aquatic mammals' gills because they begin at the same structure as an embryo. But we don't see that necessarily in the fossil record. We don't see that there was gills that turned into jaws. It's just that the same structure as an embryo either becomes gills or becomes jaws, depending on what sort of creature you are. Okay, and then the pharyngeal pouches develop in the structure of the face, neck, and chest in non-aquatic species. Okay, so let me show you some pictures of this. This is a very, very, very simple chordate, and this would be an example of an animal called a lancelet that swims around in the water. It has a notochord, this stiff tissue that supports and protects a nerve cord above it. Okay, and pharyngeal slits that started as pharyngeal pouches, which are gills in this particular animal, because it swims around, and then it has a tail past the anus, a post-anal tail. All chordates have a post-anal tail. You do too. It's just that your post-anal tail is so small that it doesn't stick out of your skin, right? You have a tailbone. You have a number of bones that go past the fusion of your back and your pelvis, and those couple of bones are your tailbone. And if they were longer, you would have a tail. But
Like it's really long.
there are people born with tails. Yes, it's a very, very, very rare developmental anomaly. And so when you were an embryo, you had a tail, and then your tailbones shrunk in the last part of your development, and the tailbones shrunk to the point where they no longer stick out past your muscles of your butt, and so your tail went away. But there are people where that truncation of the tailbone doesn't happen, and they're born with a tail. And usually when that happens, the doctor just right there cuts it off and sutures it up, and you'll never know.
Wait, is it like a bone?
Yeah.
No.
It just like stays there.
Oh,
No. People there in some like third world parts of the country where people are not born in hospitals, and the occasional random person is born with a tail, they have a tail. There are people in India actually who worship somebody who has a tail because they think he's an incarnation of their monkey god. Yes. So yeah, I don't know if when they get happy if it wags. I don't know. But there you go. So here's just again some pictures of vertebrate embryos. So pharyngeal gill pouches that'll turn into gills because this is a fish, and a post-anal tail. Here is a human embryo. Here's your pharyngeal pouches. That's going to become your jaw eventually, right? And then you have your spinal column already being supported by vertebral bones. The notochord has already served its purpose and gone away by this stage of the embryo. But here's your tail, and that'll go away as the baby develops. Okay. There are two major subphyla. Take a moment and write this down. Two minor, I think I just said major, two minor subphyla that I will cover here, and I'm not going to assign to any groups. This is cephalochordates. And Cephalochordata, there's only a couple of species of these still existing today, but we see in the fossil record that there were once many, many kinds of this sorts of creature. And they only have a notochord all the way through adulthood. One of the examples that's around today is Amphioxus. That's the genus name for it. And I'll show you some pictures in a minute. But they have a notochord only all the way through adulthood, so they never get vertebrae. They never develop a bony backbone. And these are slender finless fish. They live half buried in the sand and they filter feed. So they stick their bottom half down in the sand of the ocean, and they move water through their mouth and out their gills, and their gills catch little particles that they can eat, and they swallow the things that get stuck in their gills. And so that's how they feed. That's their life. They can swim, but they don't spend very much time free swimming in the water. They tend to only swim if they have to move to a new place. Okay, and so these guys are kind of strange looking. I don't know that we have any cephalochordates living in our waters here. I've never seen them here. I have seen them occasionally in Mexico when I've been diving there. And so we have the same sort of temperature of water, so maybe we do have some here, but I've never seen them. Then the other strange subphyla from the chordates is Urochordata. These are the tunicates. These guys don't look anything like a vertebrate. When you look at them, you're like, really? You're in my same phylum? How strange. They don't. They look more like a sea anemone than they look like a vertebrate. But when they're a larva, they have a dorsal spinal cord and a dorsal notochord, and they always have gills, and they start off with the pharyngeal pouches, and they have a postanal tail, and so the embryo looks like a chordate embryo. But then when that embryo settles out of the water, it glues its hiney to a rock, and it lives on its back, and then it goes through a metamorphosis where it no longer looks like a chordate at all, but the embryo looks like a chordate. And so because the embryo looks like a chordate, we put it in the phylum Chordata, but the adult looks nothing like a chordate. It sits there and it sucks water in one siphon hole and filters it and squirts water out the other siphon hole like a clam does. It doesn't have shells. It's an odd thing. So I'll show you some pictures in a minute. We do have these here. If you go snorkeling in the intertidal region, once you're lower than the lowest low tide line, you'll start to see these things on rocks. And they don't go very deep. So if you're snorkeling and you're 10 feet or so deep, you'll see them on rocks, and they come in all different sizes and colors, and they're all pretty small. So you gotta like look close to see them, but they're pretty cool. So this is a lancelet. This is a cephalochordate, and it's a fish, and it sucks water in its mouth, and it filters it out its gills, and this one happens to be sitting, belly down on the substrate, but usually they're buried. At least half of them or so is buried in the sand, and only their top half sticks out. So slender little funny looking fish, and those are the simplest chordates that maintain their notochord throughout their adult life. Here's a lancelet doing its thing. So he's buried in the sand, and his mouth is sticking out, and he's sucking water in the mouth and squirting it out the gills and catching little bits of stuff he can eat. And that's how he lives his life. Okay. This is a tunicate. So the tunicate larva, this is the larva of the tunicate, and you see it has a notochord, and the spinal column, I'm sorry, not spinal column, the spinal cord is here, protected by this long notochord. And this particular image, you can't see the gill slits very well, but it does have pharyngeal gill pouches. So the embryo looks like a chordate. And so because the embryo looks like a chordate, we call it a chordate. This is another picture of the embryo, right? But the adult looks nothing like a chordate. Isn't that weird looking? So yeah, it looks kind of like a sponge. So he's glued his butt to a rock, and he's secreted this protein house that looks like it should be hard like a shell, but it's not. It's squishy. It's protein. But it's not really skin either. It's kind of weird. And he sucks water in one hole and squirts it out the other. And the animal itself is living kind of tail up, mouth here, feeding off of the water that comes through here. So this is a tunicate, and it looks, as an adult, looks nothing like a chordate, but because its larva does, we call it a chordate. So these are adult tunicates, and some of them are really beautiful. Here's more of them. Okay, they're really beautiful, but they're kind of strange animals. So there you go. Take a moment and write that down. Okay, the other subphylum is where we're going to spend our time, and that is in the subphylum Vertebrata. And so these are vertebrates that have vertebrae, right? Their spinal column has turned into bone. Most of them is turned into bone. Some are cartilage, but most of them have ossified and turned into bone. And that will happen sometime during the development. They'll have a notochord as an early larva or embryo, and then before the animal hatches out of its egg, or before it comes squealing into the world, it will have replaced its notochord with some type of more rigid material, cartilage or bone. Many vertebrates are also quadrupeds. Most of them are quadrupeds, having 4 limbs. Even fish have 4 limbs. It's just that they're fins, right? If you catch a fish, it tends to have 2 pectoral fins and 2 pelvic fins, and then it has a caudal fin at the end, the post-anal tail, and then it may have some other smaller fins like dorsal fins or anal fins, but those aren't able to be wiggled. They're just like things that stick out, and they can raise or lower it, but they can't like flap it. There's on a fish there tend to be 4 fins that come out of the body that they can flap to control themselves. And so most vertebrates are also quadrupeds. And then, of course, that same design turns into the 4 limbs of reptiles, amphibians, and birds and mammals. And so the majority of vertebrates have 4 appendages. There's 2 big groups to these, and this is how your book organized it for the chapter division. Chapter 17 is over the ectotherms, which therm, you can see the idea of temperature, and ecto means outside. So these are outside temperatures. These are animals that regulate their body temperature based on their environment. And then again, endotherms. Therm is temperature, and endo means inside. So I am internal temperature. My body temperature is kept by my metabolism. So those are the 2 broad groups. The ectotherms include all the kinds of fish, and then amphibians and reptiles. And then the endotherms include birds and mammals. And then there are some reptiles that are sort of in between. There are some reptiles that maintain a body temperature higher than their environment, but not constant. So a crocodile, if you were to take a crocodile's temperature, good luck. But if you were to take a crocodile's temperature, you'll find that his internal body temperature is about 10 to 12 degrees warmer than his environment. So he doesn't always maintain like 90 degrees or something like a mammal would, but whatever his environment is, inside he's 10 or 12 degrees warmer. And so he's adding heat, but he doesn't control what that is. So there are some reptiles that are sort of endothermic-ish, but they don't regulate a body temperature like birds and mammals do. Okay? So that's vertebrates. We're going to spend most of our time there for the next 2 weeks, 3 weeks. 3 weeks. We'll be in vertebrates for 3 weeks. So obviously, this is This is a CGI image. This is a screenshot from Jurassic Park. And when they're not moving around and the theme song isn't playing, it doesn't look quite as impressive. But this is these are vertebrates that are no longer with us. But you can see the diversity of vertebrate life, from reptiles. We don't have any of these on the island. Thank Jesus. To mammals.
Oh,
wait, what happened to the basketball?
he ate it. Oh, yeah.
To
Yes.
birds and mammals. Okay. So just a real quick introduction to Agnatha, because nobody's going to do Agnatha either. And then we'll be done here. I didn't assign this to any group because we're just going to do the 6 more interesting vertebrate groups. But class Agnatha, Gnathos means jaw in Greek. And if you put an A in front of it, that means not or without. So this is jawless, right? No jaw, Agnatha. These are fish. They're vertebrates. They have a cartilaginous skeleton and a cartilaginous spinal column. But they don't have any jaws. So their mouth is like a sucker. And these are not the sucker fish that you might have in your aquarium. Okay, those animals have jaws. It's just that their lips are big and round. But these guys actually have no jaws. And they are ectoparasites. So you see the word parasite in there. Parasite, obviously, something that feeds off of the body of something else for a long time. Ecto means outside, just like ectotherms are outside temperatures. So these are fish that suck onto the outside of another fish. And then they have a rasping tongue, a tongue that's like a file. And they lick the body of the other fish until it starts to bleed. And they drink the blood that comes out of it. You would have to be really stupid to have a hagfish on you, because the lampreys and the hagfish are big. They're not like little things. They're big. And if you were to go swimming and you see this noodle-like fish swim up to you and suck onto your leg, you'd be dumb to be like, "Hey, look at you! What are you doing there?" You know, like, yeah, no, it's not something. It's not like a leech. A leech is small, and a leech's saliva numbs you, so you don't feel it. And so you've got to actually visually look down and be like, "Oh, little black worm on my leg," and cut it off. But a lamprey or a hagfish is a big thing, and it doesn't have any numbing agents in its saliva, so you will feel it start to rasp on you, and then you'd be dumb to have one on you. But fish that that don't have thumbs, you know, and can't grab the thing and pull it off, they're gonna fall victim to these guys. And so where there are lots of lampreys and hagfish in the world, you will see some other fish swimming around with another fish hanging off of it, and this fish will die at some point because it'll bleed to death, and the lamprey will then move on to something else. So suction mouth ringed with hooks protected the fish, and a rasping tongue for grinding away flesh to cause bleeding. So they're like little vampire fish, right? I do have one more slide. Creates a lot of slime as a defense. So if you're a tuna and you get a lamprey stuck to you, right? You want to get rid of the lamprey because it hurts and it's killing you slowly. And so what you might try to do is rub up against something to like scrape the lamprey off. You don't have a hand to go around and grab it. But these things create a ton of slime on the outside. So they're slippery. And if you try to wipe one off, it'll just slide by whatever you're trying to rub off on it, and it doesn't have enough friction to like pull the thing off the fish. then the creature is just going to slip out like an overcooked noodle, right? Because they're just really, really slippery. So you've got to actually like be something with a hand to hold it strongly and pull it off. Creates copious amounts of slime as a defense. Cartilaginous, no bones, and no paired fins. It only has a dorsal fin that loops all the way around its body to its caudal fin and its anal fin, and so it doesn't have anything sticking out the side. So here's some pictures now. Okay, so there's no jaw. The sucker mouth that has some hooks around it, and then this tongue in here that has a whole bunch of like filey things on it. There's another species of it.
Oh, no, thank you.
Okay. There are. Oh, don't worry about writing these down. These are other groups that you will teach. So somebody will be doing chondrichthyes, somebody will be doing osteichthyes, amphibia, reptilia, aves, and mammalia. So there are 12 of you in the class, if I'm counting right? 3, 6, 9. Just kidding. There are 14 of you. 14 into 6 groups is 2 groups of 3, and everybody else is a group of 2.